How many of you have solved it?
Sir, answer will become 12 mm.
Answer is 12 mm. Okay. Just
Sir, I
we'll
got 14.46 mm.
14.46 millimeter. Okay. Just we'll go through it and we'll check whether what is the answer. So, rest of others, what you have got? Other people, have you solved this problem? Pratik, Pratik Deshmukh, have you solved this problem? Yesterday's problem.
Hello.
Yes. Have you solved that problem?
No, sir. Only ready.
Okay. Mhm. Mari, hello. Can you hear me, Mari? Amol Mari. Okay, no problem. See, this is the problem statement. Now, yesterday's problem, which we have seen, is to determine the thickness of a 120 millimeter wide uniform plate for a safe continuous operation if the plate is to be subjected to a tensile load that has maximum value of 250 kilonewton and minimum value of 100 kilonewton. The properties of plate material are as follows. Endurance limit stress is 225 megapascal and yield point stress is 300 megapascal. The factor of safety based on yield point may be taken as 1.5. Now, yesterday, as we have talked, this problem comes under the what? Soderberg diagram, because here we are going to consider yield point instead of ultimate tensile strength. So when we are going to consider the yield point, at that time we have to use Soderberg diagram, because for the Goodman diagram and modified Goodman diagram, we have to have the ultimate tensile strength of that material, which is not given in this problem. That's why naturally we'll solve this problem based on Soderberg's equation and Soderberg diagram. Now, the given parameters, that is width is given, that is 120 millimeter. Then maximum load which is applied is 250 kilonewton. Minimum load which has applied is 100 kilonewton. And this yield strength stress is given as a 225 megapascal, that is 225 Newton per millimeter square. Then yield stress is given as a 300 megapascal, that is 300 Newton per millimeter square. And factor of safety is same, and that factor of safety we have to take as a 1.5. So when we are going to consider this factor of safety, then we can go further and let us consider first of all that T is the thickness of plate. This T we have considered as a thickness of plate. That's why naturally area of that plate is going to become as a B into T. So B is the width and T is the thickness. We know that width is 120 millimeter and we have to calculate thickness T. That's why we'll consider this area as a 120 T millimeter square. Now, as the load is fluctuating type, here if you want to insert the diagram for the load, then this load is of this type, and which is not going to become anyhow as a zero, because it will always remains to the one side, tensile side, and will not reach to the zero. So this is what the nature of load is. It is fluctuating. Again, never touches to the zero. So we have to calculate its mean stress value. Here somewhere here it a mean stress will come, and this mean stress value we have to calculate. For that, the load is given. That's why first of all we'll do the calculation for the load, and later on we will go for the stress. So mean load we will calculate first, and that mean load is given as a maximum load plus minimum load divided by 2. Okay. So maximum load is 250 kilonewton. That will convert later on in Newton, and minimum load is 100 kilonewton. So 250 plus 100 divided by 2, that will be 175 kilonewton. That is 175 into 10 raised to 3 Newton. That will be the mean load. Hence, once you are knowing the mean load, we can calculate mean stress. So mean stress, those who have solved that problem, okay, for them already we know the load divided by area is the stress. That's why 175 into 10 raised to 3 divided by 120 T, because area we have calculated in terms of T only. That's why this area which we have calculated, that area will be 175 into 10 raised to 3 divided by 120 T, and answer will be, have you calculated this answer? I have not written here. What is this value? Can anybody of you tell me?
1.458 into 10 raised to 3 divided by T.
Just a minute. Is 1.458
458 into 10
into
raised to 3
10 raised to 3
divided by T.
raised to 3 whole divided by T, right? Raised to 3. Okay. This value which we have got for the stress, mean stress. Now we have to calculate the variable stress. That variable stress value is calculated as the maximum stress minus minimum stress and divided by 2. So maximum stress is 250 minus minimum stress is 100 divided by 2. That will be 75 kilonewton, and that will be 75 into 10 raised to 3 Newton. So once you calculate that variable load, then variable stress can be calculated as load divided by area. Again, we will take the same equation and we'll calculate that 75 into 10 raised to 3 is the average or variable load, both we can consider, and A is the area, that is 120 T. So this value also we can simplify. So can anybody of you tell me what we have got for this value? Is equal to, yes, anybody of you, what?
625
625
divided by T.
10 raised to
No,
no 10 raised.
625 भागिले T.
Okay. Now, as already I have discussed that we are going to get the Soderberg diagram. And by referring the Soderberg diagram, we are going to get it as 1 over factor of safety is equal to sigma mean divided by yield stress plus sigma average divided by that is endurance limit. That means either I can write this term first or I can write this term first, no matter, because the sigma average divided by endurance limit plus sigma mean divided by yield strength, that is also right. Or we can write like this. So 1 over factor of safety we have calculated. Now we know sigma mean, we know yield stress, we know sigma average, and we know that endurance limit. So can we do the calculation and give me answer what will be the factor of safety in terms of T? A factor of safety as already as mentioned in the problem. Can you do this calculation? Hello?
11.45.
11.45. Okay.
It
Deshpande, what
will
value you are getting now? Yeah. Hello?
11.46.
11.46. Deshpande, you can write in text message what value you are getting now. Initially, how much you have got that value?
Sir,
14 point something. And now?
12.
You are not audible actually. Hello? Can you write? Okay, you have written something. Calculating. Okay. Anybody else? Abhinay Gaikwad, what value you have got?
11.46.
11.46. Okay. Anybody else?
Yes, sir. 11.46.
11.46. Okay, 11.36. Okay. So all others, they can go through it. 1 over 1.5, that is factor of safety. Sigma m is 175 to 10 raised to 3. And am I audible? Hello?
yes, sir.
Yes, sir.
Okay. Now what value which we are going to get for the variable stress is 75 into 10 raised to 3 divided by 120 T, and we are going to multiply by endurance limit, that is 225. Okay. So when we are going to calculate it, we are going to get that values, and hence we are going to get the T is equal to 11.46, and we are going to approximate it to the 11.5. Let me ask one question, that all of you, just you are listening, or what you are going to, whether you are going to take part into this? Hello?
Yes, sir, we are active.
You are active. Okay. Just take part into this, because Pratik, only listening is not sufficient. If we are going to actually take pen and paper and calculator in your hand, then and then only it is possible to go through this problem and you can understand all these problems. This is for everybody. I am not talking to the specific person. Unless and until you are not going to solve it, okay, no use of this such type of lectures and solving the problems. Otherwise, we will just have the theoretical lectures, and just like other subjects, we will talk, and I will give some points, and you'll done. Here, I expect that everybody should have calculator and pen and paper with him. So then and then only we can understand the concept. Or concept understanding is not much more difficult actually, because when we are going to go through that slide, you will understood the concept, and that is again for that, okay, for that time only. But if you again you are going to read yourself, then sometimes we may get confused in that concept, and we have to again what recall what we have studied, as well as that slide we have to recall, and later on everything which we have discussed during this lecture. So be ready with pen and paper and calculator. Okay. So next what we are going to see is the one more problem, and which is somewhat different. Here in this case, as in the previous case, we are going to consider bending stress. That is only one type of stress, either bending or principal stress, that is tensile or compressive. Now here we will consider the torsional or shear stress. Okay, when the shaft undergoes to transmitting the torque, it will undergo to the torsional stresses, whereas the torsional stresses are the basically shear stress. Again, if you go in deep, it will be combination of principal stress, that is compressive and tensile, and that shear will occur in that case. So we are not going to go in that detail, because you are learn it in any subject. But here, when we are going to consider the torsional stress, basically which is shear stress, then how we can use this Soderberg and Goodman diagram. If you are remembering, last to last lecture we have discussed about that diagram, which we can use for the shear stress also, that is for the torsional stress also. We do have that diagram. This is for the shear one, where we are going to consider the torsional stresses, shear yield strength, and shear endurance limit, that is ultimate stress and shear endurance limit. That values we need. And in that case, we can draw this Soderberg diagram, as well as we can draw this Goodman diagram, and we can draw this modified Goodman diagram also. In this case, this Goodman formula has replaced by means of this sigma to the tau. That is the only case. Okay. And this problem is related to the shear stress. First of all, I will read the statement and slowly one by one, you please solve this problem. A hot rolled steel shaft, manufacturing process is rolling. Hot rolled steel shaft is subjected to the torsional movement that varies from 330 Newton meter clockwise to 110 Newton meter and counterclockwise, that is anti-clockwise. Okay. So one can understand what will be the cycle of this loading, torsional loading. In this case, if you want to draw this cycle for the loading, then it will be like this. Where this will be x-axis, sorry, y-axis, and on x-axis it will pass like this, because the maximum load towards clockwise side, we'll say clockwise as a positive, anti-clockwise or counterclockwise as a negative. So 330 Newton meter is positive and this 110 Newton meter is negative, that is counterclockwise. Okay. So this is loading cycle, and an applied bending moment, same time bending moment is also applied on that shaft at a critical section varies from 440 Newton meter to minus 220 Newton meter. That is bending moment while the shaft is rotating. That bending moment which has generated in that shaft is 440 Newton meter, and this 220 Newton meter, that is either that plus we'll say as a tensile, minus we'll say as a compressive. That's why these tensile stresses which are generated are 440 Newton meter, and compressive stresses which are generated are 220 Newton meter. The shaft is of uniform cross section and no cleavage is present at the critical section. That means wherever we are going to do the calculation, at that point stress concentration is not there, that is QA is not present. That's why uneven surface is not there. That's why no stress concentration. Okay. Determine the required shaft diameter. Now we have to determine the diameter of that shaft. The material has an ultimate strength of 450 Newton meter square. Okay. This M is to 6. Okay. So mega Newton meter square. Here instead of giving that megapascal, here it is given as a mega Newton meter square. Okay. And the yield strength is of 410 mega Newton meter square. Okay. Take the endurance limit as a half of ultimate strength. If you are knowing the ultimate strength, which is mentioned over here, half of that is the endurance limit. It is stated in the problem. Factor of safety of 2. Factor of safety we have to take as a 2 for both the cases. That is for the variable stress also and for mean stress also. We have to take factor of safety as a 2, even in torsional stresses and even in these bending stresses. We have to take factor of safety as a 2. Then yield size factor is 0.85 and the surface finish factor is 0.62. Okay, this is what the problem statement is. Now all the given data has been mentioned over here. That is P max is 330 Newton meter clockwise, P minimum is 110 Newton meter anti-clockwise. That is minus we are going to take. We are going to consider clockwise as a positive, counterclockwise or anti-clockwise as a negative. Now its maximum bending moment is 440 Newton meter and minimum bending moment is minus 220 Newton meter. Then the sigma u, that is ultimate strength of that material, is given as a 550 mega Newton meter square, which will be equal to, you have to take care of this mega Newton. You have to convert it into Newton. Mega Newton is nothing but 10 raised to 6. So 550 into 10 raised to 6 Newton meter square. Now listen carefully, it is meter square. If you want to convert it into millimeter square, then what we have to do? Hello? If this quantity I want in Newton millimeter square, what we have to do? Can anybody of you give me answer? Am I audible?
Yes, sir.
Okay. What we have to do?
Dividing by 10 raised to 6.
Right. Dividing by 10 raised to 6. That we will get as a Newton millimeter square. So better way here only you do that in given data only, that it is 550 Newton millimeter square. Okay. Then yield strength is given as a 410 mega Newton meter square, which will be 410 into 10 raised to 6 Newton per meter square, which if you want to convert, then it will be 410 Newton per millimeter square. Then it has been mentioned in the problem that yield strength is equal to the half of the ultimate stress. So yield stress, if you want to calculate, it will be half of the ultimate stress. That's why directly it will be 275 into 10 raised to 6 Newton meter square, half of that 550 value. Okay. Factor of safety is 2. Then size factor is given as a 0.85 and surface finish factor is given as a 0.62. Now if you want to solve this problem, let us consider initially diameter of that shaft is D and later on we'll do the L calculation. Okay. So first of all, we'll calculate the mean torque which has applied and variable torque which has applied. Okay. So if this is for the torque, so mean torque is maximum torque plus minimum torque divided by 2. You have to give me value. And variable torque is maximum torque minus minimum torque divided by 2. That also you have to do. And you tell me what the value I can write for mean torque and for variable torque. In terms of D, of course, it will be in terms of D. Later on, when we are going to calculate the stress. Now here you just tell me what value will be for mean torque and variable torque. Hello. Are you doing calculation?
Sir, written in chat box.
Yeah, it is written in chat box that 110 mean torque and variable torque is 220. Okay. So whether we are going to get that value, that will check. Yes, 110 is the mean torque and 220 is variable torque. So once you calculate that torque, you have to calculate the stress. So when we are going to calculate the mean stress, shear stress, it will be 16 T, where T we have to take as the mean torque, divided by pi into d raised to 3. This formula already we are knowing. Tau is equal to 16T divided by pi d cube. So what mean value you are getting of shear stress? Hello? So I'm again going to check the chat box. So you mentioned that value in chat box. Hurry up. It is 1120 d cube. Is it? For the variable stress, and for the mean stress, it is 560 divided by d cube. Okay. Once you have got this stress, then value of endurance shear stress and yield shear stress that we have to calculate. Okay. This endurance shear stress is 0.55 of endurance limit. So endurance shear stress is 0.55 of endurance principal stress. Okay. Now it has been mentioned. Now here this you have to by heart actually, because it has not mentioned in problem statement. Okay. But while we have seen that diagram, at that time we have discussed about it. This diagram. Okay. So we'll take this as a endurance principal stress into 0.55, that will be endurance shear stress, and yield shear stress is 0.5 of yield principal stress, that we have seen while we have solved the problem related to the knuckle joint and quarter joint long back. So when we are going to calculate this value of endurance shear stress, it is 0.55 into 275 into 10 raised to 6 Newton meter square, till it is in meter square. Okay. And yield shear stress is 0.5 of 410 into 10 raised to 6. That is 205 into 10 raised to 6 Newton meter square. Okay. If you want to remove this 10 raised to 6, then it will be just Newton per millimeter square. Now, when we are going to calculate the equivalent shear stress, which is based on all the factor which we have considered, that is stress concentration factor, then surface finish factor, and size factor. This value of endurance shear limit, that is can be calculated as mean shear stress plus variable shear stress into yield shear stress into this formulae we have learned related to the principal stress, not to the shear stress. Okay, so here we will replace this principal, that is sigma, by means of shear, that is tau, and all other parameters will remain same. Okay, but only thing is that here we have to consider this factor of shear stress factor or stress concentration factor, theoretical stress concentration factor, as well as fatigue stress concentration factor as a 1, because there will not be any concentration of stress as it has been mentioned in the problem statement that no any keyway is present on that shaft. That's why we are going to assume that stress concentration will not be there. See, while we are solving problems, then we have to solve more problems if you want to understand such small, what we can say, the things which we required while solving the problems. Who can understand that this theoretical or the fatigue stress concentration factor Kf we have to take as a 1? Who will decide it? Because in problem statement it has mentioned that there will not be any keyway. It means that the stress concentration is not present. And if the stress concentration is not present, then we have to take that factor as a 1. Otherwise, it will become some 1 point something. Okay. And surface finish factor, if the surface is very smooth, then it will become 1. Because if you are going to multiply by means of that factor to the stress, then it has not to be hampered anyhow. And 1 is the value. If you are going to multiply that value with any value will not get changed. Are you getting me? Or should I repeat? Hello?
Repeat, sir.
Okay. सरफेस फिनिश फॅक्टरची व्हॅल्यू इथं 1 घ्यायची आहे. हे आपण कशावरून ठरवलं? सरफेस फिनिश फॅक्टर हा 1 घ्यायला पाहिजे. त्याची व्हॅल्यू नॉर्मली 1 नसते, 1 पॉइंट समथिंग असते, बरोबर आहे? कारण आपण मागचे जे प्रॉब्लेम सॉल्व्ह केले त्याच्यामध्ये आपण असं कळलं की सरफेस फिनिश फॅक्टर हा दॅट इज इंड्युरन्स स्ट्रेस कॉन्सन्ट्रेशन फॅक्टर किंवा सरफेस फॅक्टर किंवा साईज फॅक्टर हे फॅक्टर आहेत. हे फॅक्टर जर त्या स्ट्रेसला गुणले तर ते व्हॅल्यू कमी किंवा जास्त होते. 1 एक अशी व्हॅल्यू आहे की जी कितीही वेळा गुणली एखाद्या व्हॅल्यूला तर त्याची व्हॅल्यू चेंज होत नाही. त्यामुळे हे फॅक्टर ज्यावेळेला आपल्याला देतो प्रॉब्लेम स्टेटमेंटमध्ये दिलेले असतात किंवा आपल्याला घ्यायचे असतात त्यावेळेला त्या प्रॉब्लेम स्टेटमेंटमध्ये काहीतरी असे वाक्य दिलेले असतात की ज्याच्यावरून आपण ते फॅक्टर ठरवू शकतो. त्या ठिकाणी KF म्हणजे इंड्युरन्स स्ट्रेस कॉन्सन्ट्रेशन फॅक्टर हा 1 का घेतोय आपण? कारण प्रॉब्लेम स्टेटमेंटमध्ये असं मेन्शन केलंय की जिथं आपल्याला स्ट्रेस कॅल्क्युलेट करायचा आहे तिथं कुठलाही कीवे किंवा चेंज इन क्रॉस सेक्शन नाहीये. ज्यावेळेला चेंज इन क्रॉस सेक्शन नसतो किंवा कीवे किंवा ब्लो होल्स किंवा ड्रिल्ड होल्स तिथं नसतात त्यावेळेला आपण स्ट्रेस कॉन्सन्ट्रेशन कन्सिडर करत नाही. मग ते स्ट्रेस कॉन्सन्ट्रेशन जर कन्सिडर नाही केलं तर वी आर गोइंग टू गेट that factor as a 1. Got it?
Yes, sir.
Okay. Any question related to this? Because we'll stop today here and remaining problem or we'll see total problem again to the next lecture.